All right. Online team, let me share my screen. Okay, what is running on? Gradient descent algorithm. Okay. We are here. Logistic regression, are we done? Binary, multi-class classification we done, decision tree we done, random forest we done, k-fold cross-validation, SVM we done, underfitting and overfitting we are not done. And I still remember confusion matrix, bias, variance, and underfitting. These are all. First, you need to understand about underfitting. Then only you can understand these are all things actually. Okay, let's take a control about underfitting and overfitting after gradient descent algorithm. Okay. Now I'm trying to preparing the running notes for you. Which one, sir? Come again. Yeah. I will continue. I will continue the topic on top of the running topic I am talking actually. The continuation topic is the gradient descent algorithm and you, sir. Oh, again, okay. I forget underfitting and overfitting actually. That is 3. While the student maybe any semester is going on, writing. Papadutunda heavy rain or what? Oh, okay. Required, rain is required. But tomorrow the heat, I mean, so temperature will be underfitting. And next one will be overfitting actually. Underfitting and overfitting. Okay. Come again. Yeah. We do have. Let's take this. This one is a running topic, I can say. We are good to go. Online team, then let's move on. Make a note on this. Yeah. Let me continue. The currently running topic name is called as a gradient descent algorithm. What is the topic name? When it comes to gradient descent algorithm, make a note on this. Sir, the point will be machine learning algorithm, cost function, gradient descent algorithm works together. Works. These 3 points main motto will be increase accuracy, reduce error. Talk with me. Increase accuracy, reduce error actually. Increase accuracy, reduce error. If you want, did I run DL example in front of you? Did I run previously? Okay, sure. It shows accuracy is increasing, error is reducing actually. Maybe I have explained. Please walk through the previous recorded video. You will get an idea actually. The main motto will be these three works together and the main motto will be increasing accuracy, reduce error. How it is increasing accuracy, reduce error? Let me tell you the small process actually. The process will be in gradient descent algorithm, it is involving the first step itself. Gradient descent algorithm will pass the default parameter values. When I say parameter here, coefficient and what exactly you know, sir? Intercept actually. Talk with me. What is that? Coefficient and intercept actually. What happened? Okay. Coefficient and intercept. These are all initial parameters. Fine. These parameters, it will give hands on to the machine learning algorithm. Then machine learning algorithm will take that parameter. It will do the prediction. It will do. ML algorithm knows only prediction. But to do the prediction, it needs parameters. It needs, go back to the coefficient intercept, go to the simple linear regression. Once it's done prediction, then it's a right time. Now ML algorithm cannot talk with the gradient descent algorithm. ML algorithm will talk to the cost function. Hey, cost function, I done prediction, help me with error. Otherwise, you can tell me either my prediction is right or wrong actually. Go to the cost function topic. I already covered actually. Now, cost function will calculate the error. Cost function will calculate. Once it's calculated error, it's a right time checking time. Either error is a small or big actually. Yeah, a kind of some checking. If error is a small, sir, stop training. Training is not required. What is not required? Training is not required. If error is large actually, no. Update the parameters. What we need to do? Update the parameters actually, right? Make a note on this one. You can update the parameters. Tim, can I tell you why it got large error, because of parameters only. Because of parameters only. Best example, if parameters are really good parameter, right values actually, then you will get what exactly, sir? Small error. What error actually? Small error. If parameters are big value, kind of the values are very large values, then automatically, if the parameters are not up to the mark actually, you will get a large error. What error, sir? Large error. Once it is a large error, it never leave actually. Though error is the big error, let's leave the training. No. It will update the parameter. Then again the same process. Prediction, the same process actually. Cost function, the same process actually. Error. Did you understand or not? Right. Again the checking, small. Either the error is a small or large actually. If it is a small, stop the training. If it is a large actually, update parameters. Extend goes. Keep on, these are all things actually. Now even yesterday someone asked for a question. Let me tell you that question today actually. Let me tell you. Maybe let's open the material. From the reference point of view, I can talk actually. Go to the gradient descent algorithm. Let me talk about this. Gradient descent algorithm. Yeah, make a note on this. Gradient descent algorithm is an optimization algorithm. I'm sure you already know. This algorithm finds the values of parameter, which is something like a coefficients of what exactly? Function, and that minimize what exactly, sir? Cost function. Yeah. Then how gradient descent algorithm works. Maybe I already covered the theory. You need to walk through. Now this point is important, sir. This point is important. Can you read the topic? Convergence. What is the topic? Convergence. Let's read the theory. Trust me, you cannot understand the theory. I will explain. But understand the theory. Reaching a point in which gradient descent algorithm makes very small changes in your objective function is called as a convergence. Let me repeat again. Sir, ultimately it's supposed to reach small error. It's supposed to reach To reach the small error, it's supposed to update the parameter value. It's supposed to updating parameter value, not suddenly drastic change actually. Imagine 0 to 1, 1 to 2, 2 to 3, but not like 0 to 100 actually. But not like what exactly? Best example, imagine if there is a person, he's doing 100 mistakes actually. Suddenly he cannot stop 100. One mistake he can stop, 2, 3, 4, keep on slowly by slowly he can reduce actually. Now read the point. Reaching a point which gradient descent algorithm makes what exactly mean? Very small changes in your objective function is called as a, let me show you the diagram. I will explain the diagram also. Sir, ensure that make a note on this. Think like, see, error stays here actually, 100% error. But here error on an average, I can say the error value will be something like a 4. What is error value, sir? Error value anta cheptara? Think like it is the 4 actual. 4. Can I tell you why I'm not touching this line to this actual? Any idea? Yeah, error never be 0. Error never be 0 actually. Make a note on this one. Sir, now once you started your training, yes, error value from 100 to, it will reach to the next one. What is the next one, you know, sir? Maybe it can be 99. Then it can be 98. Then it can be, Chapan sir, it can be 95. Then it can be, keep on, it is moving actually, slowly by slowly, and it will reduce and it will reach the minimal point actually. Now please understand, the point it can be, I can say 3 actually. I mean, so let me tell you the point it can be the 4. Point it can be 4. Now can I tell you one thing? Now let me tell you, the error is not suddenly from 100 to 4 actually. Not suddenly from, that's what you need to be understand, right? Reaching the minimum point, the two doing slowly small changes is called as a convergence. What is that, sir? Error will travel always, it will travel. Sir, you know what? When I'm talking about the gradient descent algorithm, think like there is one hill, mountain. There is one mountain, kind of some peak actually, spike. Now you just try to keep your ball on top of the mountain. How the ball will travel actually? Step by step, then slowly by slowly, and it at last it will reach at one certain point actually. Am I right or not, sir? Right. Yeah, good. So it does not mean that it is reached the optimal result actually, but it is somewhat what exactly, sir? Near to that. See, uh, let me tell you, imagine 100 to 99. I cannot say this is the best point actually, but it is trying to reaching. 99 to 98, I cannot say best point. It is reaching. 98 to 95, I cannot say best point. But what I can say actually, talk with me, sir. 4 is the, so think like here you leave one ball actually. Definitely that ball, it can lies here. Am I right or not, sir? Error also same. Error also same actually. Daniel, can you tell me what is the process behind in a gradient descent algorithm? Gradient descent is a, sir, descent means decrease. Make a note on this. Ascent means increase. Gradient means error. Gradient means what exactly? Error. Descent means decrease. Error decreasing actually. Gradient descent algorithm would have, gradient ascent algorithm, I mean, first of all, error should not be increased, right? Error should not be increased, right? Gradient descent is the algorithm that finds the best fit line for, given training data set actually. If you calculate for every value of M and B, then we can get MSC value. Important, sir. The point will be, cost function need one, I hope you already know. Cost function will calculate the error value. Then when I say cost function, backend it's supposed to use either MSC, RMSC, MEI. Ante kada? Right. If we calculate, if you wanted, you can calculate manually also. I hope you already explained actually how to calculate manually. Am I right? Evaluate in, model evaluation algorithm. If you plot M value and B value with respect to the MSC actually. What is M, sir? Any idea? Coefficient. Yeah, very good. What is the B value? Intercept. What is the B value? Intercept actually, right? Then we can get the below image. See, the gradient descent algorithm looks like a bowl shape. What shape actually? Always the error is here actually. If you want, I will show you one small diagram. Open machine learning real time. Chudane, gradient descent algorithm. This diagram is really good diagram actually. Look at this one. Observe. 2 to 3 minutes you can take a time and observe actually. Please understand this. Please understand this. Good. Make a note on this one. Team, you know what? Error is here. Big error, large error. This one will be small error position. Small error position. Now gradient descent algorithm. It's supposed to travel in downwards or upwards, sir. I mean gradient descent algorithm knows what direction I need to travel to reduce the error value actually, right? Yeah. First step I can say from here to here. That is okay. The next step will be, it's not like from here to here. It can be here to here. Again, it can be here. It can be here and here and here, here. Once it is reaching here, see, slowly by slowly it is taking the steps, but it is not going, above actually. If it is going above, error is increasing again. That's what you need to understand. ML algorithm, backend gradient descent algorithm takes care about these are all things actually. Sir, you can recognize me. I'm sorry, you can remind me. So did I miss yesterday running notes or what? Right? Somebody texted actually in a Google Classroom. Okay. I didn't miss anything, right then? Okay. Okay. Thank you. Fine. Gradient descent algorithm, the image looks like kind of some bowl shape actually. So think like, with respect to the MSC, quotient value and intercept value, Daniel, I have just tried to plotted this. MSC value 0 to, like this, and M value 50, 60, 70, these are all. B value 15. Daniel, is it important actually? Not much important, just try to have an idea. Here we'll get an image which is like a bowl shape, and we need to start some value for M and B. Usually it starts from what exactly? 0. M and B is nothing but a parameters. M and B is nothing but a parameters. Update the parameters, these are all, right? Daniel, MSC with respect to the B and MSC with respect to the M, right? Ensure that, from here, this point is a really very good point, and from here to this point is what exactly, sir? Very good point actually. Okay. Steps, understand these steps. Initially, let's start the point where M value is the 0 and B value is what exactly, sir? 0 actually. Assuming that according to the diagram, MSC value, sir, we can do that actually, but frankly speaking, not required. But if you want, I do have a material, we can plot also. We can plot also, not required. Why? Because algorithm takes care of these are all things actually. Okay. Good. So assuming that according to the diagram, MSC value is 1000 and M value, B value equals to what exactly? 0. Now, can I ask a question? Sir, MSC value is big error. Value is, we got big error because of the parameters. Because of, now, if you update the parameters, automatically value error, what happens, sir? Reduce. Please important. Though this is the theory I know, but you have to be understand actually. Now, just to tune the values, tune in the sense, which one to update, which one to stable, you should get an idea actually, right? Tune. Tune, this word came from, go for radio station tuning actually. Radio station, you know about FM radio? Can I update directly like this actually? No, slowly by slowly. Otherwise, we may miss the station. Are you with me? Here parameter values also slowly by slowly. Small change actually. That is called as a tuning. That word is awesome. Tune. Right? Now check MSC value and the error will get reduced actually. Okay. Right. Once we have updated actually. Now just to tune the values. If you are touching the parameter values, automatically error rate is what exactly happening, sir? reduction, right? So we need to do this process until we'll get a minimum error, a kind of some minimum error actually. Once it reaches the minimum error, then we'll get our answer. We'll get what exactly mean our answer, right? Make a note on this one here. We need to use that m value and b values in the prediction function. What function actually? Prediction function. We need to use. These are all. This one is a diagram. Hope you know. Now I'm sure these steps you already know. The same diagram actually. Team, you know what? Yesterday I have shown one diagram, right? Can I ask you a question? M value and B value parameters are 0. Then once parameters are 0, this one is a prediction line. Can I say this is the best fitted line? No. Big error. What error? Then just to tune this parameter, then automatically the prediction will travel in this direction. Now make a note on this one. As of now, this one is a prediction. Slowly by slowly, this prediction is supposed to travel in this direction actually. In this direction. There is one question from online team. Let me look into that. Do all ML models use gradient descent algorithm to minimize error and improve performance actually? Exactly, sir. Exactly. If you want, you can customize also. How to customize, I will talk during deep learning actually. Would you have a different gradient descent algorithms? Especially 3. The first one will be normal gradient descent algorithm, mini batch gradient descent algorithm. Third one will be stochastic gradient descent algorithm. I will talk more actually. We have a different gradient descent algorithm, but understand the normal one actually. You know, mini batch, stochastic, normal gradient descent algorithm. Fine then. Now go back, sir. M value and B values actually, it is not like a suddenly change the value. M value will be slowly 0.36, B value is 0.01. Yeah, the prediction line is traveling towards to what exactly, you know, sir? Data points actually. Like this move on, I hope you already know. Values are tuned actually, you have updated and it is moving on. Again, values you have tuned actually, then it is moving on here. Wow, again the values are being getting tuned and the values are reaching here. Finally, once in 135th iteration actually, almost the prediction line is really very good actually. We know this, yeah. These are all 197, 197. I can say this one is the best fitted line. Can you tell me what is the best parameter? M equals to 1.47, B equals to? I'm sure. Hope you understand actually. Okay, yeah. Yeah, good. Let me tell you. These parameters don't think like a fixed value for the given data. These parameters actually. Imagine if the different data came actually, then values also will be getting changing. Yeah, exactly. When you're talking about the classification, then there the cost functions you need to be understand. There is a topic, the topic name is called as a confusion matrix actually. We will cover. That is upcoming topic. That is upcoming topic actually. Okay? Yeah. Hope you understand. Fine then, maybe, you know, I'm sorry, these are all diagrams yesterday we already have seen, right? ఈ diagrams అని నేను మనం చూసాం కదా. Fixed step, please make a note on this. Even just now I have shown one point. Sir, if you follow the fixed steps, then we'll get the below image. I mean to say, Daniel, from here to a kind of some, what exactly, 100 to 95, 95 to 90, 90 to 85, 85 to kind of some, you know, 70. I mean, so then definitely we are missing this point actually. It is not like a fixed steps. It is not like a fixed steps. So this approach is not going work very well actually. Then one more point will be, even learning rate and reaching minimum error. Please make a note on this one. This approach seems to be good to catch minimum error. Sir, initially from here to here that is okay. Big difference, small difference, small difference, small difference, small difference. I mean, whenever it is reaching to the, sir, let me tell you exactly like a U-turn actually. Exactly like a, whenever you're just trying to taking the U-turn actually, your speed will be very slow. But here you can go little speed actually, little speed, little speed, little speed. No, make it slow, make it slow, make it slow, make it slow. But at last it is very slow actually. You can come to the first gear also. Are you with me or not, sir? Right. This approach seems to be good to catch minimum value. The learning rate is the tuning parameter. Learning rate is what exactly? Tuning parameter. That learning rate is internally one keyword augment, it will use gradient descent algorithm. In deep learning, you will understand more details, sir. This determines the step size at each iteration while moving towards to minimum of loss function. This determines it will understand very clearly on what direction I need to travel. These are all things. Can you tell me what is the topic name? Learning rate. This one is the internal parameter, learning rate. Either it is a fixed step or else slowly by slowly I need to travel. This takes care automatically. Siddiq Sarji, you are right. Yes, you are right actually. Okay. Move on to the next one. At each point, if you calculate the slope, then we can reach the minimum value. We can reach what exactly, sir? Minimum value. If you want, I can elaborate some little math also. Back end, there is a one math topic. The topic name is called as a delta. What is the topic name? Delta actually. Those functions, it will be work in the back end. That too, it's supposed to travel in downside direction only, not upside direction. DELTA, if you want, you can make a note on this one. Then I'll do the math is important, not much important, sir. One more point you need to be understanding. Sir, whenever you're talking about the learning rate, it should not like a big learning rate, even it should not like a small learning rate. If it is the big learning rate, what happening, sir? We are missing the point. Yeah, we are missing the point actually, missing the minimum value. If it is very small learning rate, sir, it takes, imagine from here to here, here to here, here to here, here to, it takes years of the time. It takes lot of time actually. Then that's why it is called as a, a kind of some right value. It knows if you want, I'm repeating again, look at this diagram. Look at this diagram. It understands very clearly where to increase, where to decrease actually. Yeah, make a note on this one. Where to increase and where to decrease, it understand very clearly actually, very clearly. That's what you need to get a clear picture. మీకు అర్థమైందా లేదా సార్? ఓకే. A small learning rate may lead to the model takes a lot of time, some time to learn. A large learning rate will make the model converge as our point will shoot, and we will not able to get what exactly, sir? We may miss the minimum error. We may miss what exactly? Minimum error actually, minimum error. I know there are some technical words actually, we have to be understand. Perfect. That's what, when it comes to gradient descent algorithm, I'm repeating again. Explicitly, we no need to implement. But if you want, we can do also. But in deep learning, I can elaborate more and more actually. But in machine learning, this is the inbuilt actually. That's how I wanted to talk with you. Online team, are you clear? Till now, what I covered, are you clear actually? Okay. Now, now the next one, so called the topic name is called as a, we done this. This one is a underfitting and overfitting. Sir, explicitly we can apply. Can I talk more during deep learning? I mean, regarding the gradient descent algorithm, we can talk. Yeah. Why? Because there you will understand clearly. Optimizer, loss function, activation function. These are all discussion you will understand during deep learning. I can talk more. Yeah. Now, what is the topic name, sir? Underfitting and overfitting. Can I tell you? Important interview question, sir. Important interview question. And $1,000 interview question. Get ready to understand. This is very, very important actually. Okay. Make a note on this. Daniel, what is the question? What is underfitting and overfitting? Overfitting. I will explain. With a nice explanation, you will get an idea. Then get ready to understand. Get ready to understand. If you wanted to understand the topic, which is so called as a underfitting, and next one is what exactly, sir? Overfitting. Then first you need to understand about the ML steps. What steps actually? ML steps. Did you remember ML steps? Can I get your help actually? చెప్తారా ఎవరన్నా మీలో? Come again? Yeah. I'm sorry. What is the step number 1, sir? Step number 1 is so called as importing the libraries. The next one, loading the data set. Third one, sir, is it okay? Can you switch on this line? ఈ లైట్ ఒకసారి ఆన్ చేస్తారా? ఎందుకంటే ఐఎమ్ ఫీలింగ్ సమ్ వాట్ లిటిల్ స్విచ్ ఆన్. No, this one. Yeah, thank you. Then fine. Then, yeah, thank you, sir. Data preparation. The next topic is what exactly? Data preparation. Okay. Data preparation. What is the next topic? Chappan sir. Splitting the data set. Next one, model creation. Next one, model training. Next one, prediction. Sir, let me tell you this one small secret actually. Once training started, what exactly? Training started actually. Once training started, get ready. Model may face two problems. Okay, model may face two problems. Problem number one is called as a underfitting. Okay. Problem number two is called as a overfitting. I will talk more and technically. First of all, be clear. Underfitting and overfitting belongs to model training topic. What topic? ఇది మీకు చాలా క్లియర్గా అర్థం కావాలి. Let me repeat one more time. The moment when you call fit method, get ready. Model may in the sense no guarantee. Model may face two issues. These two issues we need to fix actually. Let me tell you what are those issues. Are you clear? Yeah, let me tell you. Model dot fit method, x comma y started actually. Yeah, training started. What started, sir? Training started. During training, what exactly man? Chapandi. During training, model may face two issues. Model may face two problems. Problem number one, it can be either underfitting. Problem number two, overfitting. Let me be more clear so that you can understand very clearly. First, I will talk overfitting, sir. Underfitting also I can talk, but first I like this definition. You will get an idea. Daniel, can you tell me what is overfitting? Online team, are you clear, sir? Once you understand overfitting, then I can talk about the underfitting actually. Let me tell you, what do you mean by overfitting? If you wanted to understand about this one, let me take one small example. The example would be, sir, my teacher name was Karuna Madam actually. Karuna Madam. And Daniel, what she used to teach actually? Ma'am used to teach science or maths also. Daniel, how come it is possible? I'm from ZP school, sir. Don't think like, separate subject, separate faculty. All in one actually. All faculties are expert when I was in 10th class actually. Same faculty will come and he will teach a different subject actually. Thank God. At least faculties would have actually. Right? Sir, one day, she is teaching science actually. Frankly speaking, there is one topic. One of the topic from science. One of the topic from what exactly, sir? Science. Topic from science actually. Now here is the story. In front of madam, the first person name is the Vasu. Second person name is the Nirikshan. I hope you know who is Nirikshan. Next person name is a Keshava. Next person name is a Shanti actually. Good. These are all students. Now this one is a Karuna teacher. What teacher actually? Karuna teacher. And of course, would have other students. Let me highlight only these students actually. Sir, cinema started. What do you mean by cinema? Topic is moving on actually. Can I tell you? That day, I don't know what happened. Especially that day, sir, almost the topic is over around some 20 minutes topic is over. How long time? 20 minutes already topic is over. Frankly speaking, I don't know what I don't know what is going on. My face expression will be, I don't know, maybe I'm unable to understand what is going on. My inner feeling is like this actually. Maybe the problem with me or else faculty, my feeling will be. Generally, student psychology, if student didn't understand, he will take one small turn actually. Why? Exactly, sir. Now, just I have taken one small my U-turn actually. Then I'm looking at Vasu. I'm looking at, yeah, let me tell you. Vasu is a person. He's kind of, I hope you might ever in your college also. When the madam is explaining the topic, he's rotating his head like anything, sir. Rotating actually. Rotating in the sense he's telling, ma'am, come on, I understand everything. I understand everything actually. Now, I literally got scared actually. Why? Because, then I understand problem is with me only. Sir, now here is the story. Make a note on this one. Corona teacher, by looking at this person, teacher understand, he learned the topic very well actually. During the training, Vasu is behaving, I trained very well. Talk with me. I trained very well. But when it will come outside actually, either he trained or not actually during, yeah. Let me tell you. During training, Vasu is, so Vasu is showcasing like, showcasing like, he understand the topic like anything. He understand. Vasu is rotating the head actually. Sending the vibes. So sending the vibes like, so he understand the topic like anything actually. Topic, what exactly, sir? Very well actually, very well. This word is important. Training. Now, yeah, sir, madam started conducting test actually. All right. So teacher, it's a testing time, exam time. What time actually? Exam time. Now, can I tell you? During exam, Vasu didn't written anything. The same topic, didn't written what exactly, sir? Anything. Frankly speaking, this is called as a overfitting. Simple Vasu done overaction actually. Vasu done what exactly? What do you mean by overaction? Madam, come on, I understand anything. Sometimes our machine learning algorithm also will do overaction actually. What do you mean by that? During training, model will tell, Daniel, you know what? I understand total data actually. Best example, go for my father example. Did you remember my father example? When my father is explaining image number 1 is dog son, image number 2 is the cat, image number 3 is the dog actually. I'm rotating my head. Dad, come on. I understand. But 71 image actually, testing time. Frankly speaking, I was unable to answer. Then my father beaten like anything actually. During training, I done overaction. During training, I done what exactly? Overaction, right? Now, let me tell you in a technical words actually. What do you mean by overfitting, During training, model is giving good score. Okay, model is giving what exactly? Good score actually. Then during testing, during what exactly, sir? During testing, model is not giving the good score. Not giving what exactly, sir? Good score. It is called as a overfitting. Best example, we train the model. If you want, you can check the accuracy. Once the model training is done, you are checking the accuracy. Accuracy is really very good. Though accuracy is really very good, we have a lot of faith on the model. Model works very well. Corona teacher thought like, Vasu will get 100 out of 100 actually. That much overaction he done actually. But during testing, what happened? Literally he failed actually. Literally what exactly meant? He failed. Online team, did you understand? Damn sure interview question, sir. During interview, definitely they will ask actually. Explain about overfitting actually. What do you mean by overfitting, During training, less score. What is the less score? Model. Model means algorithm. During training, model is, I'm sorry, sir. Let me take back actually. During training, model is giving good score. But during testing, model is giving model is giving, model is not giving good score actually. You can also call it as a less score or small score actually, right? Now I'm sure you understand overfitting. Now what is the next topic actually? Underfitting. And tell me, ma'am. Who can check? Who can check? Yeah, I will show you practically. Daniel, how to check training score, how to check testing score, I will check practically. I will show practically. Then you can confirm, oh, model is overfitted model. Okay. In same way. Yes, yes. Y underscore test. We need to provide actual. Same way. Same way. By using score method only. Testing data is giving, less score actual. The same way. Practical also we are doing actual. But let me tell you, the model is, during training, model is giving good score, right? What might be the reason? That reason also we need to identify. Am I right or not, sir? I will tell you. First of all, so let us just try to understand the definitions. Can you tell me what is the next topic? I'm sure during the training, model may face two issues. Issue number one, overfitting, you understand. Issue number two, what is issue number two? Underfitting. What do you mean by underfitting? Same story. Same story actually. Same story. My teacher name was Karuna ma'am, and ma'am used to teach either science or math actually. One of the topic from science, and she started teaching. Now let me tell you, during training, completely madam focused on my face only. I don't know. Sometimes in our childhood actually, faculty look at only our faces. Am I right or not, sir? I don't know what happened. Literally, my face expression, I already expressed my face will be, ma'am, I didn't understand the topic actually. Then during training itself, already Karuna teacher understand actually. This guy didn't understand the topic like anything actually. Then what about the testing? Yeah, I may fail actually. Conclusion of the story, during training, less score. During testing also, that is called as underfitting. That is called as a underfitting, right? Look at my screen, everybody. Look at my screen, everybody. At my screen. Yeah. Take all steps. Analysis time. Yeah, Daniel. Daniel, there are two issues during training. What is the first issue? What is the first one? Overfitting. Issue number one. What is the next issue? Underfitting actually. What do you mean by overfitting? During training, good score. During testing, I can tell directly less score. What do you mean by underfitting? Come on, that whole explanation I am giving in a very simple way. During training itself less score. Then what about the testing? Less score only. Less score only. Are you clear about this one? These two are the problems. Now, can I ask a question? What is actually problem here? There are two problems. Which one is the major problem actually? Exactly, sir. See, did you understand? This is serious problem. This is, anyway model is not giving good score actually. We can think about why it is not giving good score actually. But when it comes to here, sir, model is blaming us. model is telling, sir, you can deploy me and I will give the good score actually. Then during the testing it is failing. అంటే ఇక్కడ ఏది నిజంగా ప్రాబ్లం అంటే, what is the actual issue is overfitting is danger zone. Indirectly overfitting is telling I am very good actually, this is the score I am giving. You can just have to send for prediction actually. I will do the prediction, but during prediction it is failing actually. I mean to say that it is blaming us. It is, are you with me or not, sir? But when it comes to underfitting, anyway during training only less score actually. Why we can send for prediction? We never send, right? మీకు ఈ పాయింట్స్ అన్ని అర్థం కావాలి యాక్చువల్గా. థియరీ డిస్కషన్, ఐ హోప్ యు నో. నో, ఐ నీడ్ టు టాక్ విత్ ఆన్లైన్ టీమ్. Yes, sir. Overfitting is doing overaction actually. Let me drink water. Sir, you are not scolding me, right? Just I'm asking. Just kidding, sir. Let's open the material. I will tell you why. Why these issues also I will tell you. Let's move on to the material. Can you talk with me? Underfitting and overfitting, right? Yeah. Yo, I need to explain one word actually. It's okay. Let me explain. Make a note on this. Sir, the main goal of any machine learning model is, this word is important, sir. Generalize well. Come and talk with me. Generalize. One more time. What do you mean by that? Let me tell you. This word is important. Doing prediction on unknown data. Doing good prediction. Doing good prediction on unknown data. Unknown data set is called as a generalized well. Is called as what exactly, sir? Is, I will tell you, is called as generalized well. I will tell you one more time, don't worry. Even I can talk with you, you will get an idea. Okay, please understand the story. First understand the point here actually. Go back. Let's take area. Rice packs. 110, 220, 330. Sir, 110, 220, 330, known data, well-known data. What data? Well-known actually. I mean to say, this one is called as a well-known. I can say well-known actually. Well-known. Yeah. But it's the right time. I am planning for prediction. Sir, unknown data. Talk with me. Unknown data. What is unknown data? 4. Then what is the prediction value? Talk with me. 40. Now read the definition, you will get an idea. Doing good prediction. Doing what exactly? Good prediction on what data set? Unknown data. Go to my father example. That 30 images is unknown for me actually. But still I am doing prediction. That is called as a generalized well. What do you mean by generalized? You know? That's why take a data set. We are splitting 70-30 ratio. 70 well known. Why? Because training happen actually. But 30 unknown. But still it is unknown data set. Then it is doing the prediction. The main goal of any machine learning algorithm is generalize well. What do you mean by generalize? A generalized model provides a suitable output on unknown data set. What data set? Unknown data set. This means after providing the training on data set, it can produce trustable result. What result, sir? Trustable, a kind of some reliable actually. Yeah, overfitting and underfitting are the two main problems that occur machine learning. Because of these ML models, performance may impact to reduce actual. Conclusion of the story. Yes, we are expecting models supposed to work very well. But during training, there may be a chance we may get 2 issues. What is the issue number 1? Overfitting. Issue number 2? Underfitting. Okay. Noise. There are some keywords you need to be understand. Noise means irrelevant data. It reduces the performance of the model. Let me tell you, hey Daniel, why underfitting and overfitting? Why? Because you have loaded the data, but you didn't process the data properly. Then it can impact actually. During the training, it can impact actually, right? Data may mess up with noisy data. Noisy means, noise means irrelevant data. And bias. What do you mean by bias? Also called as a cost, loss. Difference between actual value and predicted value is called as a bias. What is the next one? Variance. What is the next one? Variance. Can you read this word actually? Machine learning model perform well with the training data set, but does not perform with what exactly? Yeah, imagine, kind of some exactly underfitting issue actually. You can still also call as a variance. Come again. Machine learning model perform well with the training data set, good score, but does not perform with what exactly? Test data set, bad score actually. Oh, sorry, sir, overfitting. Overfitting actually, but what is exactly variance will be? Not this definition. This is 50% of the definition. I will talk with you actually, right? What exactly happened? Data set changed actually. Daniel, why? Think like during training, my father have given cat and dog images. My father have given cat and dog, but during testing, my father bought donkey images actually. I may fail. Are you with me or not, sir? Right. Yeah, you're right. Overfitting. I'm sorry. Online team, are you clear? I just need one response from you. Are you clear, sir? Siddiq Sarji, hold on. You will understand. Sir, there is one image I will show you. Please look at that image. You will get an idea. Now this image is required. Yeah, bias variance trade-off. Sir, here we are going to spend some time. Let us make a note actually. The point will be errors are two types. One is the bias error. The next one will be variance error. One is the bias. What do you mean by bias? The difference between actual value and prediction value, which is so called as a bias. What do you mean by variance? Come on, I'm repeating again. Bias means the difference between actual value and what exactly? Prediction value. You can also call as a cost. Bias, cost, loss, error. These are all similar terminology actually. What do you mean by variance? Variance means sometimes the data set may change actually. Sometimes the data set, what exactly? May change. That too during training period. Best example, if the data set then small changes, during that time you may get a variance error. What error, sir? Can I give one small example? Go back to my father example. Total how many images? 100. All images, what are all type of images? Cat and dog. Just before training, I have a brother. We have a big fighting each other actually. A kind of some big mess up happened actually. Then my brother is waiting for revenge. My brother is waiting for what exactly? Am I right? In a blood relation, these are all things it will be happen actually. Then once the training started, sir, what happened? My brother came suddenly. My brother, he is holding the hand in front of my father and he is telling, Father, you started training, right? Really good actually. I have a few more images. I have what exactly? Already I frustrated with 100 images actually. My brother is giving suggestion to my father. I have a few more images. Take these 20 images and give the training actually. Let me tell you that 20 images are irrelevant images. What images? Now here is a story. During training, if the data set then small changes actually, you will get a variance error. You will get what error? But this one is very rare case actually. We have to include this point also. Meeku ardhamaindalade sir? Yeah, good. Sir, go back ML flow. Go back to the ML flow. Yeah. Simple man. That's what my father example is very, very important. Yeah, get ready. You have to make a note actually. What is the first one? Bias. Chappan sir, what is the first one? Bias. The next one will be variance. Variance. Look at the diagram. First of all, this diagram is very, very important, sir. This diagram is very, very important. Think like there are some three circles, circle number 1, circle number 2, circle number 3. The middle point is so called as a red dot. That is a target. That is what exactly I hope you might have heard about archeries actually, right? That target is really important. Please remember, there are two column names, low variance and high variance. Come on, one more time. Low variance and high variance. There are two rows actually, low bias and what exactly? High bias. Come on, one more time. Low variance, high variance, low bias, high bias. Sir, almost 4 combinations would you have? 4 combination. 4 combination. Let me tell you, combination number 1. Combination number 1. Low bias value and low variance value. What is the low actually? Small. What is the low actually? Small. Small bias, small variance. Frankly speaking, this is really good place actually. Maybe having some network issue. Online team, I can sense I lost. I lost. Having some network issues. Online team, can you hear me? No, I lost. Can you hear me? But I don't know, here it is showing some network issues. It's okay. If you are able to hear, no issue from my side also. Let's continue. Let's continue. Sir, this is very, very important, sir. This diagram is very, very important. Whenever you're talking about the machine learning, even previously you guys asked, even yesterday someone asked a question. When it comes to gradient descent algorithm, how it will decide which one is the best error? This is the diagram. This is the diagram. What is the diagram, sir? Imagine gradient descent algorithm. It will just try to talk with, it's supposed to need small bias value. It's supposed to need small variance value actually, right? Now, sir, every machine learning algorithm target is this one only. What do you mean by the target actually? Low bias value. The next one will be, Chappan sir, low bias value. Next one, low variance is really good place. This is also called as a sweet spot actually. What spot, man? Sweet spot for machine learning algorithm. Right. Once you done training, ML algorithm may reach this place actually. If ML algorithm is reaching this point, trust me, this is the best position actually. That is the best position. Best position. Now let me explain about the second position. What is the second position, sir? Can you tell me? Low bias value. And next one is what exactly? High variance value. This position is so called as a, what this position is so called as? Go back. One minute. No. Online team, hold on. I'm searching for one definition. Here itself. Oh, maybe underfitting, overfitting only. Can you tell me underfitting? First of all, what is the general definition for underfitting? During training, good score. During testing, less score. Come on, one more time. What do you mean by overfitting? I'm repeating about, so let me talk about the overfitting. Overfitting definition will be during training, good score. During testing, less score. This is general definition. But if you want more and technical, whenever you're talking about the overfitting model having low bias value, high variance value. That position is called as a overfitting model. What model actually? Ayo sir, this position exactly, low bias value, high variance value, model is overfit actually. Okay, model is overfit. I'm pretty sure by looking at this diagram, you can easy to understand model is overfit model actually. I will show you how to calculate bias and variance also, so that you will get a more clarity. I know it is a theory, but more interesting theory I guess actually. Am I right or not, sir? Come on, let me repeat again. Sir, every machine learning algorithm, they need a target. The target will be low bias value and what exactly? Low variance value. Frankly speaking, if machine learning algorithm having low bias and low variance, this part is seriously awesome, sir. Your model will do the good prediction. Model will do good prediction. Scenario number 1, you can keep it away. Scenario number 2, model may face low bias value. Yeah, Daniel. Model may face the combination will be high variance value. Sir, this is the conclusion. You can just have to check actually. Model is overfitting model. What model? Overfitting model. We have to fix the issue. We have to fix the issue actually. Right. Can I give one small definition? Yeah, good. Overfit. Overfitting. General definition. Technical definition. General definition just for your better understanding. During training, good score. During testing, less score. Daniel, can you tell me that technically? Yeah, I can tell you. What do you mean by overfitting? You know, overfitting means equals to, చెప్పండి sir, low bias. Yeah, low bias plus high variance. During interview, you need to write like this actually. That guy will understand very clearly. Okay, you know about the overfitting actually. This is more on technical. This is more on general actually. Right. I mean, if I explain directly this one, you cannot understand. That's what I explained like in a general way actually. Did you understand or not, sir? Good. Now, Daniel, now overfitting you understand. Next one will be, I wanted to tell you what is good model. What is good model? Also called as a good algorithm actually. What is good model or good algorithm? You know, I will tell you. Yeah. General definition I will tell you. The next one will be technical definition also. I'm sure you understand what I'm going to deliver actually. Cheppandi sir. Cheppandi during training, good score. During testing also, good score. Yeah. Then during testing also, good score. That is called as a good model. That is called as a good model. Can you tell me technically? Very good, sir. Very good actually. Right. You know, technically, good model means low bias plus low variance. If you really understand these are all discussion what I'm talking with you, such a nice discussion, sir. You know, I simplified in a very layman terminology actually. Layman terminology. Sir, model, either it can be good model or else overfitting model or else underfitting model. Come on, let us have a definitions actually. Whenever you're talking about the models, Daniel, whenever you're talking about the models, good model, it can be good model. It can be overfitting model. You know, overfitting model actually. Tell me, it can be underfitting model. I'm pretty sure you are getting more clarity actually. You are getting more clarity. Only these three types. There is no other one actually. Talk with me. What is the first one? Good model means training good score, testing good score. Technically tell me, low bias, low variance. Simple. Close the discussion. Sir, overfitting. During training, showcasing high score, good score. During testing, less score actually. Technically, low bias, high variance. Yeah. The next one will be underfitting. Let me continue. Are you comfortable? Feeling boring? No, right? Yeah. Let's continue. Very good. Very good. Thank you. Thank you for understanding. These are all nice discussions, sir. These are all nice discussions actually. What about you online team? Rajesh sir, I will tell you how to check that. I will tell you how to check. We have a separate discussion, sir. We do have a separate discussion. Don't worry. Somebody is asking underfitting. Look at the definition, sir. What do you mean underfitting? You know, high bias and low variance. Talk with me. High bias and low variance. What is the combination? Then here you need to look at the diagram. High bias value and low variance value. This combination is called as an underfitting combination. Sir, good model, overfitting model, underfitting model. I am repeating again. Look at the diagram. Look at the diagram. Good model, overfitting model, underfitting model. These three scenarios are very, very important actually. Ignore this. First of all, ignore this scenario. This is not at all important actually. High bias and high variance. Sir, first of all, model is literally worst model actually. Why? Because error also high actually. Bias error also very high. So variance also very high actually. But let me tell you one small point. If bias is reducing, sir, variance will increase. If variance is reducing, bias will increase. That relation it is having actually. The difference between bias and variance I can talk more later actually. And sir, if bias is increasing, variance will reduce actually. If variance is increasing, what exactly happen? That kind of relationship it is having. Then ultimately, low bias value required. The next one will be low variance value. Reaching that point will be algorithm takes care. Algorithm takes care. These are all very high level discussion. I can talk actually. You'll get an idea. Sir, that is possible. That is yeah, absolutely possible, sir. That is also called as we can fine tune the model. Imagine if the model having a kind of some high error actually, we can apply kind of some hyperparameter tuning technique and we can get the good model actually. If the model is not good model, we should not leave. You need to apply some extra technique to get the good model actually. Okay. Siddiq Sarji, I hope you understand. Whatever I am covering the theory from yesterday onwards, whoever all attended all ML session, you guys only can understand. If you are having any gap in between the session, I request you, please walk through previous sessions also so that you will get a more clarity. Can you please explain again what it mean by bias actually? Karthik Sarji, we have a separate discussion. So I will explain. But anyway, I'm talking about the underfitting and overfitting actually. Tell me. Come again, sir. One more time. Images. What is your doubt actually? Yeah, let me tell you. First of all, this point means nothing but think like a prediction values. This points is nothing but a prediction. If it is a low bias and low variance, these are all good prediction. This one is actual value, prediction value also near to the actual value. But when it comes to high variance, on an average, these are all prediction. I can say on an average some 20 points actually. Out of 20, 5 are good prediction, but remaining are all wrong prediction actually. I hope I'm clear, I guess. All right. These are all prediction. This dot indicates to the prediction. Dot indicates to prediction. Sir, this is very far from actual value. This is the very far from actual value. This is the why model is behaving like this, because of the overfitting model. Because model is overfitted actually. Yeah, good. Here itself, no way. And here also, this is something like a throwing a stone actually. Imagine, there is a mango tree, we are throwing the stone. Either it can hit or not, we don't know actually. But here you are giving guarantee. You are giving guarantee actually. Take this model works very well. Model works what exactly mean? Very well actually. Now I can talk with you. Are you clear till now? Online team, I need a response from everybody. I need a response from everyone, sir. My kind suggestion, once the topic is over, immediately kindly please walk through. This image also I need to upload. Remind me this image for today. Sorry, man. Now this theory you can understand. Now here we are underfitting and overfitting. Now this one is a continuation topic actually. Now I am sure I have explained these are all little theory. Let us just try to walk through. We already covered. Overfitting is the scenario. Team, did you remember during the polynomial regression, degree value should not be 9. If degree value should not, if it is like 9, 10, 12, it is, yeah, overfitting. It is touching all data points. A good prediction line should not touch the data points. It's supposed to be near, as close as possible. That day I told you, it is overfitting issue. What issue? Here is that overfitting actually. Okay. Models 3 types, man. Good model, overfitting model, underfitting model. Good model is okay. Even underfitting model is not a problem. We need to fine tune the model. But what is the problem? Overfitting model is, blaming us actually. Online team, I can keep holding your question. Let me continue. The overfitting model. See, sir, underfitting. Frankly speaking, during training itself, it is failing actually. Just right fit. Yeah, good. Don't think like, this line is supposed to touch all data points actually. If the line is touching almost all data points, overfitting. Go back to the polynomial regression. If you are giving degree value 3, 4, that is okay. But if you are giving, either you notice or not, if you are giving the degree value is the 9, it will touch each and every data point actually. How come it is possible, sir? Highly impossible actually. Make a note on this in real time. Who can, yeah. Till now I have explained overfitting. It's a right time you need to be understand. Daniel, I wanted to apply the fix for overfitting. I don't want overfitting model actually. These are all solutions. Solution for overfitting actually. We can avoid overfitting issue by using k-fold cross-validation. By using, if you apply k-fold cross-validation, it takes care automatically. Right? That is one of the approach. And training with more data. Train with, best example, if you train with just a matter of 5 to 6 rows actually, model will be overfit. Model will be overfit actually. And removing features. Removing sometimes unwanted features we have to remove actually. Because of that feature also, model may overfit actually. What is the last one? Regularization, which is so called as a L1, L2, also called as a lasso regression and ridge regression, which is upcoming topic. The next one will be ensemble technique. Can I talk with you? These are all solutions to fix overfitting model. I'm repeating again. These are all solutions. What is the first one? Use k-fold cross-validation. That is really very good actually. Training with more data. Removing features actually. Regularization. L1, L2 also called as a lasso regression and ridge regression. The next one is called as a ensemble technique. What technique, sir? Ensemble technique actually. Make a note on this. These are all solutions. How to fix the overfitting issue. This is the answer actually. Make a note on this. Cool then. This I will continue tomorrow. Online team, just now I'm looking at your questions actually. Siddiq Sarji, ML models 4 types from training and testing. Okay. Nageswara Sarji, sir, is variance calculated while making the prediction on the testing data set? So it's calculated when doing the training actually. Nageswara sir, tomorrow we are doing that practical. How to calculate variance, how to calculate bias. Practically we are implementing tomorrow actually. You will get an idea. And Siddiq Sarji, should we say 3 or 4 types of ML models from the prediction score viewpoint actually? Sir, 3 models, sir. Good model, overfitting model, underfitting model. That's it. Okay. I'm talking about after training. I'm talking about after training, you can divide the models like a good model, overfitting model, underfitting model. Okay, all right. So I hope the discussion, really good questions online team we have triggered actually. Fine, let me, I need your help, kind help actually. Let me upload the material. Is it still raining? ఇంకా వర్షం పడుతుందా? Yeah, please, you can short let you go. I can take care about how to upload the material. I'm sure till now I didn't miss anything. If I miss anything, let me know. I can help you actually. Let me just try to upload the new material for today, which is so called as a first. What is the topic name, sir? Underfitting and overfitting, right? And then running notes, then image actually. Yeah, Daniel. Daniel, underfitting and overfitting. Yeah. Then along with this one, running notes I need to upload. Let us add here our material content, and it is very well structured actually. And I need to upload running notes too. Go back here. Here I need to upload. Yeah, I need to upload these running notes, right? Yeah, good. Yesterday should be 100. Now image also. Yeah, thank you, sir. Thank you, thank you. Then let us upload gradient descent algorithm also from real time, I guess actually. Okay. Go back to my material, D drive, Daniel, uh, materials, machine learning, real time, media, gradient descent. This is the image, I guess, I'm sure. Thank you, man. Thank you, thank you, thank you. We'll connect again tomorrow. Don't miss tomorrow's session. Be regular, actually. Sir, please, you can connect with me. Yeah, boss.